Hello and welcome back to the Sleepy Darwin. Whether you're here to let your mind drift into gentle wonder or simply to find some peace at the end of a restless day, you've arrived at exactly the right moment. Tonight, we're embarking on a quiet exploration of something happening all around you right now. An endless, patient experiment that's been running for nearly 4 billion years. From the bacteria quietly evolving in your morning coffee to the flowers outside your window testing new ways to catch a bee's attention, nature is the universe's most tireless scientist, constantly trying new approaches, new solutions, new ways of being alive. This is the story of evolution, not as a finished masterpiece, but as an ongoing laboratory where everything, including you, is both the experiment and the experimenter. Now, before we begin this gentle journey through time and possibility, if you enjoy these sleepy explorations into science, a like and subscribe truly help this little corner of curiosity grow. And I'd love to know, where are you listening from tonight? And what time is it where you are? Are you in a bustling city or somewhere quiet where you can hear the night sounds of nature's own experiments continuing? I do hope this isn't so fascinating that it keeps you wide awake, but if it does, at least you'll drift off knowing you're part of something beautifully, endlessly creative. So settle in, let your breathing slow, and let's discover why the laboratory of life never closes. Picture this, if you will. You're lying there, perhaps in your favorite corner of the world, maybe with a soft blanket pulled up to your chin. And as you listen to my voice, I want you to imagine something extraordinary. Beneath your feet, or perhaps beneath the building you're in, beneath the soil and the bedrock, there's something remarkable happening. You're resting on the surface of what might be the most sophisticated laboratory that has ever existed. This laboratory we call Earth has been running continuous experiments for 4.5 billion years. That's a number so vast it almost loses meaning, doesn't it? Let me put it in perspective for you. If you could live for 1 million years, which would make you incredibly ancient by human standards, you would need to live that entire million-year lifespan 4,500 times over to witness the full duration of Earth's experimental program. And here's what makes this laboratory so different from any human-built research facility. It never stops. There are no weekends, no holidays, no funding cuts that shut down promising research. While you sleep tonight, millions of experiments are continuing in tide pools and forest floors, in the depths of ocean trenches, and in the microscopic spaces between grains of soil. But perhaps the most beautiful thing about nature's laboratory is that it operates by rules entirely different from human science. When we humans design experiments, we start with hypotheses, educated guesses about how the world works. We carefully control variables, we plan our methodology, we predict outcomes. Nature does none of this. Instead, nature conducts what we might call blind experiments. There's no planning committee, no research proposal, no peer review process. A cosmic ray strikes a strand of DNA, altering a single letter in the genetic code of a bacterium. A landslide separates a population of beetles, cutting off their gene flow. A mutation causes a bird to grow slightly longer wings. These aren't planned experiments, they're accidents, really. Beautiful, random accidents that nature then tests against the ultimate criterion. Does this change help the organism survive and reproduce? Think of it like this. Imagine you're baking bread, and instead of carefully measuring out raisins to distribute evenly throughout the dough, you simply scatter them randomly. Some areas of the bread will have clusters of raisins, others will have none at all. Some raisins will end up perfectly positioned, others might be right at the edge where they'll burn slightly. But here's the magic. Nature doesn't just bake one loaf. It bakes millions and millions of loaves, each with a slightly different pattern of raisins. The mutations, our genetic raisins, are scattered through the populations of every living thing in patterns that seem random, chaotic even. But just like our bread analogy, some of these random distributions turn out to be surprisingly delicious. A random mutation gives a moth better camouflage against tree bark. Another random change allows a deep-sea fish to produce its own light. Yet another accident of genetics helps a flower attract exactly the right kind of pollinator. And unlike human bakers, who might throw away the loaves that don't turn out perfectly, nature keeps all of its experiments running simultaneously. The moth with slightly worse camouflage doesn't get discarded. It continues living, breeding, contributing its own variations to the great experimental mix. The deep-sea fish that glows a little less brightly still finds its place in the ecosystem. The flower that's not quite as attractive to pollinators might still catch the attention of a different kind of insect altogether. Let that image settle in your mind for a moment. The vast, patient laboratory of Earth, conducting countless experiments every second, with no preconceptions about what should work, simply testing everything that could work against the beautiful, impartial judge of survival and reproduction. Take a slow, deep breath and feel yourself part of this grand experiment. The oxygen you're breathing was itself an experiment. Billions of years ago, tiny blue-green bacteria began releasing this gas as a waste product, not knowing they were creating the atmospheric conditions that would eventually allow creatures like you to exist. Now, you might be wondering, as you settle deeper into your comfortable position, what makes all these experiments possible? What does nature pay with to conduct this endless research program? The answer is both simple and profound. Nature pays with time, energy, and generations. Time is perhaps the most generous resource in nature's experimental budget. While human researchers might have a few years of funding, nature operates on a completely different timescale. Consider the evolution of the eye, something so complex that it once seemed impossible to imagine how it could have evolved gradually. But nature had 600 million years to work on this problem. 600 million years of tiny improvements, generation after generation. Imagine if you had that kind of time to perfect something, let's say, playing the piano. If you could practice for 600 million years, starting with just the ability to press one key, adding one tiny improvement each day, you wouldn't just become a good pianist. You'd probably evolve entirely new forms of music that we can't even imagine. That's what nature does with every biological challenge it encounters. Energy is the second currency, and nature spends it lavishly. Right now, as you listen to my voice, your heart is pumping, your brain cells are firing, your digestive system is working. All of this requires energy. And you're just one organism among trillions on Earth, all simultaneously spending energy on the grand experiment of being alive. But here's where it gets beautifully inefficient. Nature doesn't just spend energy on the organisms that will survive and reproduce successfully. It spends energy on all the experiments, including the ones that won't work out. The butterfly that emerges with wings that are slightly the wrong color for effective mating displays still got all the energy needed to develop those wings. The tree seedling that germinates in a spot with too little sunlight still received all the nutrients and energy needed for germination, even though it might not survive to maturity. From a human engineering perspective, this seems wasteful. But from nature's experimental perspective, it's essential. Because you never know which seemingly failed experiment might turn out to be perfectly adapted for changing conditions. That butterfly with the wrong wing colors might be exactly what's needed when the environment shifts. That tree seedling that can't compete in full sunlight might be the ancestor of a whole lineage adapted to deeper shade. The third currency is generations, countless generations of living beings, each one a fresh opportunity to test new combinations of traits. And here's where nature's experimental method becomes almost magical. The butterfly effect, where tiny changes can cascade into enormous consequences. Picture a single moth, born with wings that are just a shade darker than its parents. This tiny difference, perhaps the result of a mutation affecting just one gene, makes it slightly better at hiding from birds during the day. Because it survives a little longer, it has more opportunities to mate. Its darker-winged offspring inherit this advantage, and they too survive better and reproduce more. But the story doesn't end there. Because these moths are living longer, they're also eating more of the plants they feed on as caterpillars. This changes the plant community in subtle ways. Some plants become less common, others expand into the newly available space. The insects that depend on those plants shift their populations accordingly. The birds that eat those insects adjust their feeding patterns. The seeds that those birds spread as they fly to new feeding areas establish plants in different locations. One moth, with wings just a shade darker, sends ripples through an entire ecosystem. Not immediately, not dramatically, but gently, persistently, like the way a pebble dropped in a still pond creates circles that eventually reach the shore. DNA serves as nature's laboratory notebook, meticulously recording the results of every experiment. But unlike human lab notebooks, which are written in neat handwriting or typed in organized files, DNA's records are written in a four-letter alphabet: A, T, G, and C. These letters, strung together in sequences, billions of letters long, contain the instructions for building every living thing on Earth. What's remarkable is that you can read the history of experiments in these genetic sequences. Scientists can look at your DNA and see evidence of ancient experiments that your ancestors participated in. There are sequences that reveal when your mammalian ancestors developed the ability to see in color. There are genes that show when they evolved the capacity to digest milk as adults. There are even sequences that carry echoes of our fish ancestry, instructions for growing gills that are still present in our genetic code, though they're turned off during human development. Imagine nature as a patient artist, working not with paint or clay, but with the very fabric of life itself. Unlike human artists, who might sketch out their ideas first or plan their composition, nature works more like a jazz musician, improvising endlessly, building on whatever musical phrase came before, never knowing exactly where the melody will lead but trusting in the process of creation. This artist never rushes, never grows impatient with a line of experimentation that seems to be going nowhere, never abandons a project because it's taking too long to show results. The experiments with flight took hundreds of millions of years to produce birds. The experiments with intelligence took even longer to produce creatures capable of contemplating their own existence. And still the artist continues, brush in hand, adding new details to the vast canvas of life, layer upon layer, generation upon generation. As you continue to relax into this journey through nature's experimental mindset, I want to share with you one of the most comforting realizations about how nature defines success. It's quite different from how we humans typically think about success and failure, and understanding this difference might just change how you see your own place in the grand experiment of existence. In human terms, we often think of success as achieving our goals, meeting our expectations, or outperforming others. Failure, conversely, is falling short of these marks. But nature operates by an entirely different definition of success. Success is simply continuing to exist, to adapt, to find a way to thrive in whatever circumstances arise. This means that nature doesn't create failures in the way we understand them. Instead, it creates beautiful experiments in adaptation, each one perfectly suited to its particular time and place. What we sometimes call evolutionary failures are really just experiments that worked wonderfully under one set of conditions, but faced new challenges when those conditions changed. Let me tell you the story of the dodo, but not the version you might have heard before. We often speak of the dodo as a symbol of evolutionary failure, a bird so poorly adapted that it inevitably went extinct. But this perspective misses something crucial. The dodo was actually a remarkable success story that lasted for millions of years. Picture the island of Mauritius, as it existed for millennia before humans arrived. No large predators, abundant food sources, a tropical paradise where a ground-dwelling bird could thrive. In this environment, the dodo's flightlessness wasn't a disadvantage, it was an optimization. Why waste energy growing and maintaining large flight muscles when you don't need to escape predators? Why develop quick reflexes when there's nothing dangerous to react to quickly? The dodo's round, sturdy body was perfect for efficiently processing the fruits and seeds that made up its diet. Its fearlessness toward other creatures wasn't stupidity, it was the logical result of millions of years without natural predators. The dodo was beautifully, perfectly adapted to its world. It was nature's successful experiment in island living, in peaceful coexistence, in a life where the energy normally spent on vigilance and escape could instead be devoted to simply being. The dodo's extinction wasn't an evolutionary failure, it was the collision between one successful experiment and another. Humans represent nature's experiment in intelligence, tool use, and global mobility. When these two experiments met, the dodo's millions of years of perfect adaptation to a predator-free environment became a vulnerability in the space of a few decades. But even in extinction, the dodo continues to serve the experimental process. Its story teaches us about island evolution, about the delicate balance of ecosystems, about the responsibilities that come with the kind of power that humans wield. In a sense, the dodo's legacy continues to inform nature's ongoing experiments with intelligence and consciousness. This pattern repeats throughout the history of life. The trilobites, those intricate sea creatures that dominated Earth's oceans for 270 million years, weren't failures when they finally went extinct. They were successful experiments in marine living that taught nature countless lessons about body armor, compound eyes, and navigating ocean environments. The giant ground sloths that once roamed the Americas weren't poorly designed when they couldn't adapt to changing climates and human hunting pressure. They were successful experiments in large-bodied herbivory that thrived for millions of years. Every extinction provides data for future experiments. When the dinosaurs faced their great extinction event 66 million years ago, the ecological niches they left empty became opportunities for other experimental lineages. Small mammals, which had been living in the shadows of the great reptiles, suddenly found themselves in a world full of possibilities. Nature took the lessons learned from 165 million years of dinosaur experiments and applied them in new ways. What if we made large herbivores that were warm-blooded instead of cold-blooded? What if we created social hunters that could coordinate their attacks through vocal communication? What if we developed herbivores that could process tough grasses in complex digestive systems? The fossil record becomes nature's experimental journal, documenting not just what worked, but what worked where and when. The Burgess Shale, that famous deposit of fossils from 505 million years ago, shows us nature in full experimental mode during the Cambrian explosion. Creatures with 5 eyes, organisms with no modern equivalent, body plans that seem almost alien to our current understanding of life. Most of these experimental forms didn't persist, but they all contributed data to the great research program of evolution. Some of nature's most important innovations came from what initially appeared to be failures or accidents. The evolution of sexual reproduction, for instance, seems inefficient from a purely reproductive standpoint. Why should an organism pass on only half its genes when it could clone itself and pass on all of them? But sexual reproduction turned out to be nature's solution to the problem of genetic stagnation, creating the genetic diversity that allows populations to adapt to changing conditions. Similarly, the evolution of aging and death seems counterproductive. Why would natural selection favor organisms that deteriorate and die? But programmed aging turns out to be part of nature's experimental strategy, ensuring that each generation doesn't occupy ecological niches forever, making room for new genetic combinations to be tested against environmental challenges. Even our human tendency toward anxiety and worry, which can feel so uncomfortable, represents nature's experimental approach to survival. The humans who inherited genes for anxiety were the ones whose ancestors were cautious enough to avoid dangers, plan for potential problems, and survive long enough to reproduce. Our capacity for suffering isn't a design flaw, it's part of nature's experimental toolkit for keeping us alive and motivating us to solve problems. As you rest there, breathing slowly and naturally, consider this. You are not just observing nature's experiments, you are one of them. Every human who has ever lived has been nature's attempt at something slightly different. Your particular combination of traits, your unique perspective on the world, your individual way of solving problems and relating to others, all of this represents nature's ongoing experimentation with consciousness, creativity, and community. And here's perhaps the most beautiful part. There are no failed human experiments, only different approaches to the magnificent challenge of being conscious, creative, and caring beings in a complex world. Every person who has lived, every culture that has flourished, every individual story of struggle and growth contributes to nature's understanding of what it means to be human. Every creature that ever lived was nature's attempt at something, an experiment in surviving, in adapting, in finding new ways to transform energy and matter into the phenomenon we call life. And that includes you, resting peacefully as you listen to these words, breathing easily, your heart beating steadily, your magnificent brain processing language and imagery and emotion, all of it part of nature's most ambitious experiment yet. Matter that has become conscious of itself, star stuff that has learned to contemplate stars. Take a moment to feel the profound privilege of being part of this ancient, ongoing research program. You are both scientist and subject, observer and experiment, a conscious note in nature's eternal song of discovery and adaptation, and endless, beautiful becoming. As you settle deeper into your comfortable space, perhaps pulling that blanket a little closer, I want to take you on a journey through one of nature's most ambitious experimental programs. Close your eyes if they aren't closed already, and imagine looking up at the sky on a warm summer evening. What do you see moving through that vast blue canvas above you? You might see a butterfly dancing from flower to flower, its wings catching the golden light like stained glass windows. Perhaps a bird glides overhead, effortlessly riding invisible currents of air. Maybe, if you're lucky, you'll spot a bat beginning its twilight hunt, moving through the air with an alien grace that seems almost magical. And all around you, though you might not notice them, tiny insects are performing aerial acrobatics that would make our best pilots envious. What you're witnessing is the result of one of nature's most persistent and creative experimental programs, the conquest of the sky. And here's what makes this story so remarkable. Nature didn't solve the problem of flight just once and then copy that solution everywhere. Instead, like a brilliant inventor who keeps finding new ways to achieve the same goal, nature independently discovered flight at least 4 separate times, and each time, it found a completely different solution. Let me share with you the story of these 4 great aerial experiments, each one a masterpiece of biological engineering, each one as different from the others as a helicopter is from a hot air balloon. The first experimenters to take to the skies were the insects, beginning their aerial adventures somewhere around 400 million years ago. Picture the world then, vast forests of primitive plants, no flowers yet, no grass, no creatures with backbones walking on land. In this ancient world, the first insects began to experiment with flight in a way that remains unique to this day. Insect wings didn't evolve from arms or legs, as they did in all the other flying creatures. Instead, they appear to have developed from gill plates, respiratory structures that helped early insects breathe. Imagine the beautiful accident that first occurred when one of these gill plates caught the wind and provided just enough lift to help an insect escape a predator or reach a new food source. From that humble beginning, nature began its first great aerial experiment. Insect flight is unlike anything else in the natural world. Their wings move in complex figure-8 patterns, twisting and flexing in ways that create tiny hurricanes of air. A dragonfly's wings can beat independently of each other, allowing it to hover, fly backward, or change direction instantly. It's like having 4 separate helicopters working in perfect coordination. The physics of how they achieve this was so complex that it took human engineers centuries to understand it, and we're still learning from their techniques. But nature wasn't satisfied with just one approach to flight. Around 230 million years ago, during the age of dinosaurs, another group began their own aerial experiments, the pterosaurs. These were not birds, not bats, not insects, they were flying reptiles, and their solution to flight was unlike anything that had come before or has evolved since. Pterosaurs built their wings from skin membranes stretched between elongated finger bones, particularly one incredibly extended 4th finger. Imagine stretching your ring finger until it was longer than your entire body, then growing a membrane of skin from that finger to your body and legs. It sounds impossible, yet pterosaurs perfected this design so well that some species grew to have wingspans larger than small airplanes. The largest pterosaur, Quetzalcoatlus, had wings that spanned more than 30 feet. Yet despite their enormous size, these creatures were master flyers, capable of soaring across vast distances, diving for fish, or delicately plucking small prey from the ground. They ruled the skies for over 150 million years, a testament to just how successful this particular flight experiment was. Then came the birds, beginning their aerial experiments around 150 million years ago. Birds took yet another approach entirely, one that seems almost elegant in its simplicity compared to the complex wing mechanics of insects or the dramatic stretched membranes of pterosaurs. Birds modified their arms, extending them and covering them with feathers, structures that are among the most sophisticated biological materials ever evolved. A single feather is a masterpiece of engineering. It's lightweight yet strong, flexible yet structured, and capable of precise adjustments that allow for incredibly fine control of airflow. Birds don't just flap their wings up and down, they twist them, adjust the angle of individual feathers, create slots between their primary feathers to reduce turbulence, and perform countless other tiny adjustments that make their flight look effortless. And finally, much more recently in evolutionary terms, came the bats beginning their flight experiments only about 50 million years ago. Bats chose yet another solution, creating wings from membranes stretched between elongated finger bones, like pterosaurs, but doing it completely differently. Where pterosaurs used primarily one giant finger, bats spread their wing membranes across multiple fingers, creating a more flexible, more controllable wing surface. Bat wings are like living sails that can change shape instantly. They can adjust the camber of their wings mid-flight, alter the surface area, even create different wing shapes for different parts of each wing beat. It's as if they're flying with wings made of liquid, constantly reshaping themselves for maximum efficiency. Now, here's where this story becomes almost mystical in its beauty. Think of these 4 solutions to flight like different ways of filling a balloon. You could blow air into it with your lungs, you could use a pump, you could fill it with helium, or you could heat the air inside it. Each method fills the balloon, but each one works through completely different principles and has different advantages and disadvantages. Insects fill their balloon of flight with rapid, complex wing movements that create lift through mechanisms that seem to defy the basic principles of aerodynamics as we first understood them. Their approach works perfectly for small, lightweight creatures that need incredible maneuverability. Pterosaurs filled their balloon with enormous, membranous wings that were perfect for soaring and gliding, allowing them to become the largest flying creatures that ever lived. Their solution worked beautifully for creatures that needed to cover vast distances efficiently. Birds filled their balloon with feathered wings that provide the perfect balance of power, control, and efficiency. This solution has proven so successful that birds have diversified into nearly 10,000 species, from tiny hummingbirds to massive albatrosses, each one fine-tuning the basic bird flight plan for their particular lifestyle. Bats filled their balloon with flexible membrane wings that work beautifully in the dark, allowing for the precise control needed for echolocation-guided flight. Their solution opened up the nocturnal niche that birds had largely left unexplored. Let me take you into the world of one of nature's most extraordinary flight experiments, the hummingbird. As you rest there, imagine a creature so small it weighs less than a penny, yet capable of aerial feats that seem to mock the laws of physics. A hummingbird's wings don't just flap up and down like other birds. Instead, they rotate in a figure-8 pattern, much like insect wings, but with a uniquely avian twist. On both the upstroke and the downstroke, the wings generate lift. It's as if the hummingbird has found a way to make every moment of wing movement contribute to staying airborne. The mathematics of hummingbird flight is beautiful in its precision. Their wings beat at rates of 50 to 80 times per second, so fast that they create that characteristic humming sound that gives them their name. To achieve this, their flight muscles make up 25 to 30% of their total body weight. Imagine if 30% of your body weight was muscle devoted to a single activity. That's the level of specialization these tiny birds have achieved. Their hearts beat over 1,200 times per minute during flight, pumping the massive amounts of blood needed to supply oxygen to those incredibly active flight muscles. Their metabolisms run so hot and fast that they must feed almost constantly, visiting hundreds of flowers each day. They're living at the very edge of what's physiologically possible for a warm-blooded creature. Yet watch a hummingbird at a feeder, and what you see looks effortless. They hover motionless in mid-air, then dart sideways, backward, upside down, performing aerial ballets that seem to ignore gravity entirely. They're nature's tiny helicopters, but far more graceful and efficient than anything humans have built. This brings us to a profound realization about nature's experimental approach. Each of these 4 solutions to flight didn't just solve the problem of getting into the air, they opened up entirely different ways of living in the world. Insects use flight for everything from finding mates, to escaping predators, to dispersing to new habitats. Birds have used flight to colonize every continent, to migrate across entire hemispheres, to dive deep into oceans and soar high into the stratosphere. Bats use flight to hunt in complete darkness, navigating and capturing prey through sound alone. Each solution to flight became the foundation for thousands of different experiments in how to live an aerial life. And nature continues to experiment with flight even today. Some flying squirrels have evolved the ability to glide between trees using membranes stretched between their limbs. Flying fish use their modified fins to glide above the ocean surface. Some spiders use silk balloons to drift on air currents, effectively flying without wings at all. As you breathe slowly and feel yourself relaxing deeper, consider this beautiful truth. Nature tried flight over and over, each time differently, each time discovering new possibilities in the sky. There was no single right way to fly. There were many right ways, each perfect for different circumstances, different lifestyles, different dreams of what it might mean to leave the ground behind. The sky above you right now is filled with the descendants of these 4 great experiments. each one still testing new variations, still perfecting their particular approach to the ancient dream of flight. And in some small way, every time you've ever flown in an airplane, you've been participating in humanity's own ongoing experiment with flight, our attempt to join the vast aerial laboratory that has been running above our heads for hundreds of millions of years. Now, as you continue to rest in your comfortable space, I want you to try something. If your eyes are open, close them gently. If they're already closed, just notice the darkness behind your eyelids. In a moment, I'm going to ask you to open them again, but first, I want you to appreciate something we almost always take for granted, the miracle of sight. The ability to see, to transform patterns of light into meaningful information about the world is so fundamental to how we experience reality that we rarely stop to wonder how extraordinary it is. But from nature's experimental perspective, vision represents one of the most persistent and creative research programs in the history of life. And like flight, it's a problem that nature has solved not just once, but dozens of times, each solution as elegant and unique as a different way of painting a sunset. When you open your eyes now, you're using the result of one particular experiment in vision, the camera-type eye that we share with other vertebrates. But scattered throughout the living world are dozens of other solutions to the challenge of seeing, each one a masterpiece of biological engineering, each one opening up different possibilities for how to sense and navigate the world. Let me take you on a journey through nature's vision laboratory, where the experiments have been running for over 500 million years, and where new innovations in sight are still being tested even today. The story begins in the ancient oceans, around 540 million years ago, during that explosion of creativity we call the Cambrian period. It was then that nature first began serious experimentation with the conversion of light into information. The earliest eyes were simple, light-sensitive spots that could distinguish between light and dark, bright and dim. Imagine having vision that could tell you whether you were in sunlight or shadow, but nothing more. It seems primitive to us, but for creatures living in a world that had never known sight before, even this simple ability was revolutionary. From these humble beginnings, nature began to experiment with different approaches to vision. Some lineages developed compound eyes. Imagine having not one lens, but thousands of tiny lenses, each one capturing a small piece of the visual world and contributing to a mosaic image. Other lineages experimented with camera eyes, single lenses that focus light onto a sensitive surface, much like the cameras we use today, or like your own eyes. But nature didn't stop there. Some creatures developed mirror eyes that use curved reflective surfaces to focus light. Others created scanning eyes that build up images by moving their field of view across the world, like radar sweeping across the sky. Still others developed pinhole eyes that work without any lens at all, creating images through the simple principle that light travels in straight lines. The most familiar type of eye to us is our own camera eye, and it's worth pausing to appreciate just how remarkable this particular solution is. Your eye contains a clear, flexible lens that can change shape to focus on objects at different distances. Behind that lens is a light-sensitive surface called the retina, packed with over 100 million light-detecting cells. These cells don't just detect light, they perform the first stages of visual processing, enhancing edges, detecting motion, adjusting to different light levels. But here's what makes the story of vision even more amazing. Camera eyes like ours have evolved independently multiple times. We share this type of vision with other vertebrates, but octopuses, squids, and other cephalopods independently evolved remarkably similar camera eyes. When you look into the eye of an octopus, you're seeing the result of a completely separate experimental path that arrived at nearly the same solution. Yet the octopus eye is subtly different from ours in ways that reveal the different experimental approaches nature took. Our eyes have a blind spot where the optic nerve connects to the retina, but octopus eyes don't. Their wiring is organized more efficiently. It's as if nature took two different routes to the same destination and learned something different from each journey. Now let me introduce you to one of nature's most spectacular vision experiments, the compound eyes of insects and crustaceans. Instead of one large lens, these creatures have thousands of tiny optical units called ommatidia, each one like a miniature telescope pointed in a slightly different direction. A dragonfly's eye might contain 30,000 of these tiny visual units, giving it a field of view that covers almost 360 degrees. Imagine being able to see in nearly all directions at once. detecting the slightest movement anywhere around you. This type of vision sacrifices the fine detail that our camera eyes provide, but it excels at detecting motion and provides an incredibly wide field of view. The compound eye is particularly fascinating because it reveals something profound about nature's experimental philosophy. It's not trying to create the best possible vision in some absolute sense. Instead, it's creating vision that's perfectly adapted to particular ways of life. A dragonfly needs to detect the movement of small prey insects while simultaneously watching for predators that might approach from any direction. For this lifestyle, compound eyes are superior to camera eyes. But nature's vision experiments become truly mind-bending when we encounter creatures like the mantis shrimp. These remarkable marine animals have developed what might be the most complex vision system on Earth. While we humans can see 3 primary colors, red, green, and blue, mantis shrimp can see 12 to 16 different types of color. They can see deep into the ultraviolet range and far into the infrared. They can detect polarized light and even circular polarized light, types of illumination that are completely invisible to us. Imagine trying to describe the visual world of a mantis shrimp to someone who has never seen color. How would you explain what it's like to see ultraviolet patterns on flowers, patterns that evolved specifically to guide pollinators? How would you describe the experience of seeing polarized light patterns in the sky that create a navigation system invisible to most other creatures? The mantis shrimp's vision system is so complex that scientists are still trying to understand how their brains process all this visual information. It's as if they're seeing not just a different view of our world, but an entirely different world altogether, one painted in colors we can't imagine, revealing patterns and information that are completely hidden from our experience. This brings us to one of the most beautiful aspects of nature's vision experiments. Each type of eye doesn't just see the world differently, it reveals different aspects of reality. The compound eyes of a bee can see ultraviolet landing strips on flowers that are invisible to us. The infrared vision of certain snakes allows them to hunt warm-blooded prey in complete darkness. The polarized light vision of many marine animals provides them with a compass that works even on cloudy days. Some creatures have evolved eyes specifically for seeing in the deep ocean, where sunlight never penetrates. These eyes are enormous relative to body size, designed to capture every photon of the faint bioluminescent light produced by deep-sea creatures. Other animals have evolved eyes for life in caves, where they've discovered that vision is unnecessary and have allowed their eyes to degenerate, redirecting that evolutionary energy toward enhanced senses of hearing, touch, and smell. Even more remarkably, some creatures have evolved multiple types of eyes simultaneously. Certain spiders have 8 eyes arranged in different patterns, with each eye specialized for different visual tasks. Some have eyes optimized for detecting motion, others for seeing fine detail, still others for vision in dim light. But perhaps the most profound vision experiment of all is happening right now, in your own brain, as you process these words. The act of reading involves converting patterns of light and dark into meaningful symbols, then transforming those symbols into concepts, images, and emotions. Your visual system is not just passively recording what's in front of you, it's actively constructing your visual reality, filling in blind spots, enhancing edges, making assumptions about 3-dimensional space based on 2-dimensional information. Your brain is conducting its own ongoing experiments in vision every moment you're awake. When you see an optical illusion, you're witnessing your visual system making educated guesses about reality that sometimes turn out to be wrong. When you see a face in the clouds or find patterns in random noise, you're experiencing your brain's experimental approach to making sense of visual information. And here's something wonderful to consider as you rest there. Every creature with eyes is conducting similar experiments in making sense of the visual world, but each one is constructing a slightly different version of reality. The bee sees ultraviolet patterns, the hawk sees tiny movements from vast distances, the deep-sea fish sees bioluminescent signals, the mantis shrimp sees a rainbow beyond our imagination. What does it mean that nature keeps reinventing sight? Perhaps it suggests that reality is so rich, so full of information, that no single approach to vision can capture it all. Each type of eye reveals different aspects of the world's complexity. Together, all of nature's vision experiments create a collective understanding of reality that's far richer than any single perspective could achieve. As you settle deeper into relaxation, consider this. Every time you open your eyes, you're participating in one of nature's most ancient and ongoing experiments. The light entering your eyes right now has traveled vast distances to reach you, perhaps from the sun, perhaps reflected off the moon, perhaps from artificial sources powered by energy that ultimately came from ancient sunlight trapped in fossil fuels. That light carries information about the world, and your eyes, your brain, your entire visual system is nature's experiment in extracting meaning from that information. You are both the scientist and the instrument in this experiment, both the observer and the observed, participating in the same research program that began 500 million years ago and continues every time any creature anywhere opens its eyes to see. As you continue to rest peacefully, breathing slowly and naturally, I want to invite you to imagine something beautiful. Picture yourself shrinking down, becoming very small, until you're standing at the entrance of an ant colony. What you're about to witness is one of nature's most fascinating experiments, the emergence of collective intelligence. The individual ant standing near you is, by most measures, a simple creature. Its brain contains perhaps 250,000 neurons compared to your 86 billion. It has no concept of the grand architecture of the colony it belongs to, no master plan for the complex society it's helping to build. Yet somehow, when thousands of these simple individuals come together, something magical emerges, a collective intelligence that can solve complex problems, adapt to changing conditions, and create sophisticated structures that seem to require planning and coordination far beyond what any individual ant possesses. This is nature's experiment in what we might call emergence, the phenomenon where simple components, following simple rules, combine to create complex behaviors and capabilities that none of the individual components could achieve alone. And like all of nature's great experimental themes, this one has been explored in countless different ways across the living world. Let me take you into the warm darkness of a beehive, where tens of thousands of individual bees are conducting one of nature's most sophisticated social experiments. Each bee follows relatively simple behavioral rules. When you find a good food source, return to the hive and dance in a pattern that indicates the direction and distance. When you detect a pheromone signal indicating danger, respond appropriately. When the temperature gets too high, fan your wings to create cooling airflow. But from these simple individual behaviors emerges something extraordinary. A superorganism that can regulate its own temperature within a few degrees, make collective decisions about where to forage, defend itself against threats, and even make democratic choices about where to establish new colonies. The hive knows things that no individual bee knows. It can solve problems that no individual bee could even understand. The bee's waggle dance is particularly beautiful as an example of nature's experimental approach to communication. When a forager bee discovers a rich patch of flowers, she returns to the hive and performs a figure-8 dance on the vertical comb. The angle of the dance relative to vertical indicates the direction of the food source relative to the sunday. The duration of the straight run in the middle of the figure-8 indicates the distance farther sources require longer dance runs. But here's what makes this truly remarkable. Other bees watch these dances and use the information to fly directly to food sources they've never visited before. The dancing bee is essentially giving precise GPS coordinates using only movement and timing. It's a form of symbolic communication that was evolving in beehives millions of years before humans developed language. Yet the most extraordinary social experiments in nature might be happening beneath your feet right now, in the vast fungal networks that connect the roots of plants. These networks, sometimes called the Wood Wide Web, represent nature's experiment in creating biological internet systems. Imagine, if you will, lying down in a forest and somehow being able to see the hidden connections beneath the soil. You would discover that most of the plants around you are connected by an intricate network of fungal threads finer than spider silk. These mycorrhizal networks stretch for miles, connecting not just individual plants, but entire forest communities. Through these networks, plants can share resources. A large tree with access to sunlight can send sugars through the fungal network to smaller plants growing in its shade. In return, those smaller plants might share different nutrients they've acquired from the soil. When a tree is attacked by insects, it can send chemical warning signals through the network, allowing other trees to begin producing defensive compounds before the insects reach them. The forest becomes a collective intelligence, a community where information and resources flow freely between individuals who are technically competitors. Old trees become like wise elders, nurturing younger plants and sharing the chemical wisdom acquired over decades of experience with pests and diseases. But perhaps the most complex social experiment nature has ever conducted is the one we're part of, human society. Our species has taken the basic concept of collective intelligence and pushed it to extraordinary extremes. We've developed language symbolic communication so sophisticated that we can share not just information about immediate threats and resources, but abstract concepts, stories, plans for the future, and knowledge accumulated over thousands of generations. Your ability to understand these words right now is part of this experiment. Language allows us to share the contents of our minds with each other in ways that no other species can match. When I describe the waggle dance of bees, information that was gathered by researchers through years of careful observation is transmitted to your mind in seconds. You're receiving the accumulated knowledge of our species about another species' communication system, a meta-level of information sharing that represents the cutting edge of nature's social experiments. Human culture represents nature's experiment in non-genetic inheritance. While other species pass on information through genes, we also pass on information through teaching, storytelling, writing, and now digital media. We've created institutions, schools, libraries, universities, governments that exist longer than any individual human life and accumulate knowledge and wisdom across generations. Our cities are like vast anthills, but instead of being built by creatures following simple instinctual rules, they're built by conscious beings who can imagine different possibilities and choose between them. Yet even our conscious choices often lead to emergent properties we didn't plan or expect. Traffic patterns, economic systems, cultural trends, all emerge from the complex interactions of millions of individual decisions. The internet represents perhaps the newest phase of nature's social experiments. For the first time in Earth's history, individual organisms, humans, have created a global communication network that allows nearly instantaneous information sharing across the entire planet. We're conducting real-time experiments in global collective intelligence, and we're still discovering what capabilities might emerge from this unprecedented level of connectivity. Social media, online collaboration, crowdsourcing, and other digital phenomena are all part of nature's ongoing experiment in what happens when you connect billions of intelligent minds through rapid communication networks. Like the early stages of any evolutionary experiment, we're seeing both remarkable innovations and significant challenges as we adapt to these new social environments. But nature's social experiments aren't limited to obvious social species like ants, bees, and humans. Even bacteria conduct social experiments through a process called quorum sensing. Individual bacteria can detect the density of their own population by sensing chemical signals produced by other bacteria. When the population reaches a certain threshold, the entire bacterial community can switch to new behaviors, perhaps forming protective biofilms, or producing toxins, or beginning to disperse to new locations. This means that even the simplest living things on Earth participate in collective decision-making processes. The bacteria in your gut, the microbes in soil, the plankton in the ocean all are conducting ongoing experiments in social coordination and collective behavior. Some of the most beautiful social experiments happen in flocks of birds or schools of fish, where thousands of individuals move together in fluid, coordinated patterns without any centralized control. Each bird or fish follows simple rules. Stay close to your neighbors, avoid collisions, move in the average direction of nearby individuals. From these simple rules emerges the breathtaking choreography of murmurations and the seamless coordination of schooling fish. Scientists have discovered that these animal groups often make better collective decisions than the individuals within them could make alone. A school of fish can find food sources more efficiently than individual fish. A flock of birds can navigate more accurately during migration than any single bird. The group becomes smarter than its members. As you rest there in your comfortable space, consider that you are part of multiple social experiments simultaneously. You're part of your family, your community, your culture, your species. You're connected through invisible networks of relationship, communication, and mutual influence. The thoughts you're thinking right now have been shaped by thousands of social interactions throughout your life. Even in your solitude, you're not truly alone. The language you think in was developed collectively over thousands of years. The knowledge you possess was accumulated and shared by countless generations. The very concepts you use to understand yourself and your world are products of our species' long experiment in collective intelligence. And here's something wonderfully mysterious. Just as ant colonies and beehives seem to possess emergent properties that transcend what individual ants and bees can understand, human societies might be developing collective capabilities that transcend what individual humans can fully comprehend. Perhaps our global civilization is becoming something like a planetary nervous system, with individual humans as neurons in a vast, emerging mind. Societies like cosmic fog, swirling into new patterns, condensing here into institutions, dispersing there into movements, always in motion, always experimenting with new forms of organization, new types of relationship, new ways of being together while remaining individual. As you drift deeper into relaxation, imagine yourself as both an individual consciousness and a participant in this vast social experiment. You are unique and irreplaceable, yet you're also part of something larger than yourself, networks of relationship and communication that extend across your community, your species, and increasingly, through our growing understanding of other species' social experiments, across the entire community of life on Earth. Now, as you rest there in the quiet of this moment, I want to invite you to stretch your imagination across vast spans of time. Let's slow down together. Let your breathing become even more gentle and relaxed, because we're about to embark on a journey that requires a different kind of thinking, the kind of slow, patient contemplation that matches the rhythm of nature's deepest experiments. Imagine, if you will, that you could watch the history of life on Earth like a very slow movie, where each second of the film represents 1,000,000 years of real time. The entire movie would last only about 4.5 hours, representing the 4.5 billion years since our planet formed. For more than the first hour of this movie, you would see no life at all, just oceans and volcanic landscapes under alien skies. When life finally appears, it would be invisible to your movie camera for almost 3 more hours. These would be the ages of bacteria and archaea, conducting countless microscopic experiments in chemistry and energy processing, slowly but fundamentally transforming the planet's atmosphere and oceans. Only in the last 40 minutes of our deep time movie would you begin to see the kind of complex, multicellular life forms that we usually think of when we imagine ancient creatures. But oh, what those last 40 minutes would show you. Around the 4-hour mark in our imaginary film, you would witness one of nature's most explosive, experimental periods, the Cambrian explosion. In just a few minutes of movie time representing about 20 million years of real time, you would see an almost unbelievable burst of creativity as nature experimented with virtually every basic body plan that would ever evolve. Picture this ancient ocean, around 540 million years ago, suddenly teeming with experimental creatures that seem almost alien to our modern eyes. There was Opabinia, with 5 mushroom-shaped eyes and a long proboscis ending in a grasping claw. There was Hallucigenia, so strange that scientists initially couldn't tell which end was the head and which was the tail, covered in spines and walking on stilted legs. There was Anomalocaris, a meter-long predator with grasping arms at the front of its head and a circular mouth filled with teeth. These weren't evolutionary mistakes or primitive attempts at modern forms. They were nature conducting wild, creative experiments in what it might mean to be a complex, multicellular animal. Most of these experimental body plans didn't persist, but they weren't failures, they were explorations. Attempts to discover what kinds of solutions were possible for the challenge of being a complex creature in a complex world. The Cambrian explosion reveals something profound about nature's experimental approach. When new possibilities open up in this case, the genetic and developmental tools needed to build complex bodies, nature doesn't carefully test one possibility at a time. Instead, it launches into an almost manic phase of creativity, trying thousands of different approaches simultaneously. It's like an artist who suddenly gains access to a whole new palette of colors and begins painting dozens of canvases at once, exploring every possible combination and technique. But nature's deep time experiments aren't just about periods of explosive creativity. They're also about patience, the kind of deep, geological patience that's difficult for creatures like us, with our brief lifespans, to truly comprehend. Consider the evolution of photosynthesis. the process that plants use to capture energy from sunlight. This innovation, which seems so fundamental to life as we know it, took nearly 2 billion years to perfect. 2 billion years. Let that sink in as you rest there. If you lived for 80 years, you would need to live that entire lifetime 25 million times over to witness the full development of photosynthesis. And during much of that time, the experiments with photosynthesis were actually poisoning the planet from the perspective of most existing life forms. Early photosynthesis produced oxygen as a waste product, and oxygen was toxic to most of the life forms that existed then. The rise of oxygen levels in Earth's atmosphere caused one of the largest mass extinction events in the planet's history, sometimes called the Great Oxidation Event. From our perspective, we might see this as a disaster, but from nature's experimental perspective, it was a massive reorganization that opened up entirely new possibilities for life. The oxygen crisis forced life to experiment with new forms of metabolism that could not only tolerate oxygen, but actually use it as a fuel. This led to the evolution of more complex cells with specialized internal structures, and eventually to the complex multicellular life that includes us. What seemed like a catastrophic poisoning of the planet was actually a crucial step in a vast experimental program that would eventually produce the rich, diverse biosphere we inhabit today. This pattern of apparent disasters that turn out to be opportunities for new kinds of experiments repeats throughout Earth's history. Mass extinctions, which have occurred at least 5 times in Earth's past, might seem like the ultimate failures of nature's experimental program. But from the deep time perspective, they reveal themselves as something more like hitting the reset button on a vast, complex simulation. Each mass extinction cleared away dominant life forms that had been successful for millions or tens of millions of years, but whose success was preventing other experimental lineages from exploring new possibilities. When the dominant species disappeared, suddenly there were empty ecological niches everywhere, new opportunities for entirely different approaches to being alive. The extinction event that ended the age of dinosaurs 66 million years ago is a perfect example. The dinosaurs had been successful experimental subjects for over 150 million years, diversifying into an incredible array of forms from tiny feathered creatures to massive long-necked herbivores. But their success meant that mammals remained small and largely nocturnal, constrained to the evolutionary margins. When the asteroid impact ended the age of dinosaurs, it wasn't just a catastrophe, it was also an opportunity. Suddenly the world was full of vacant niches, large herbivore niches, large predator niches, aerial niches, aquatic niches. The mammals, which had been conducting their own quiet experiments in small body survival for millions of years, suddenly had room to explore entirely new possibilities. In the relatively brief span of 10 million years after the extinction event, brief by geological standards, mammals diversified into forms as different as bats and whales, elephants and humans. It was another explosion of experimental creativity, comparable to the Cambrian explosion but involving creatures much more familiar to us. But perhaps the most remarkable thing about nature's deep time experiments is how they reveal the incredible patience of the experimental process. Consider the evolution of intelligence, something we humans are naturally interested in because we represent its current cutting edge. The first nervous systems appeared around 600 million years ago, simple networks of nerve cells that could coordinate basic responses to stimuli. For hundreds of millions of years, these nervous systems gradually became more complex, experimenting with different arrangements of nerve cells, different ways of processing information, different strategies for coordinating behavior. The first recognizable brains appeared around 500 million years ago. For the next 450 million years, nature experimented with countless variations on the basic theme of centralized information processing. Fish brains, reptile brains, early mammal brains, each one a different approach to the challenge of creating a biological computer. Only in the last few million years, the blink of an eye in geological terms, did these experiments produce the kind of intelligence capable of contemplating itself. The human brain, with its capacity for abstract thought, language, and self-reflection, represents the current pinnacle of a 600 million year experimental program in biological information processing. And yet, from the deep time perspective, even human intelligence is just another experimental phase. We might be nature's attempt to create matter that can understand itself, but we're probably not the final form this experiment will take. The story of intelligence is still being written, still being tested against the challenges of existence. This deep time perspective offers a profound kind of comfort. When we face challenges in our brief human lives, when changes seem too rapid or too overwhelming, it can be soothing to remember that we're part of experimental processes that have been running for hundreds of millions of years. The patience of geology, the slow wisdom of evolutionary time, the vast experimental programs that have produced everything from the first photosynthetic bacteria to the most complex ecosystems on Earth. You are resting now in just one moment of this vast experimental timeline. Your life, precious and unique as it is, represents just one data point in nature's ongoing research into what it means to be a conscious, feeling, thinking creature. But you're not just a passive subject in these experiments, you're also an active participant, making choices, adapting to challenges, contributing your own small but meaningful variations to the great experimental themes. As you breathe slowly and feel yourself settling deeper into relaxation, consider the incredible privilege of existing during this brief moment in Earth's experimental history. You are living in an age when nature's experiments have produced creatures capable of contemplating the experimental process itself. You can think about thinking, wonder about wondering, dream about the deep timescales on which these vast experiments unfold. Our brief moment in this endless laboratory is just that brief. But it's also precious beyond measure, because we represent nature's current attempt to understand itself through conscious awareness. Every moment of wonder you experience, every insight you gain, every connection you make with other people or other forms of life is part of this grand experimental program that has been running for billions of years and will continue for billions more. Now, as you continue to rest peacefully, I want to take you on perhaps the most mind-bending journey yet in our exploration of nature's experimental laboratories. We're going to shrink down, smaller and smaller, until we enter a world that's usually invisible to us, but which is actually the most active experimental workshop on the entire planet. Imagine becoming so small that you could swim in a single drop of water. What you would discover there would astonish you. This tiny droplet contains more living creatures than there are people in a major city. And every single one of these microscopic beings is engaged in experimental activities that are reshaping our world in ways both subtle and profound. Welcome to nature's microscopic workshop, where the pace of experimentation is so rapid and the number of participants so vast that more evolutionary experiments are conducted in a single day than might occur in larger organisms over millions of years. Let me introduce you to the bacteria, nature's most prolific and creative experimenters. While we often think of bacteria as simple, primitive creatures, the truth is quite the opposite. Bacteria are experimental virtuosos, master inventors who have been perfecting the art of rapid adaptation for nearly 4 billion years. What makes bacteria such remarkable experimenters is their approach to genetic innovation. While complex creatures like us can only pass genes to our offspring through reproduction, bacteria have evolved something far more revolutionary. They can share genetic material directly with each other, even across different species, in a process called horizontal gene transfer. Imagine if you could acquire new abilities not just from your parents, but by directly receiving skills from any other person you encountered. That's essentially what bacteria do with genes. A bacterium that has evolved resistance to an antibiotic can share that resistance gene with other bacteria, even bacteria from completely different species. A bacterium that has learned to digest a new type of food can share that capability with its neighbors. This means that bacterial populations can adapt to new challenges with astonishing speed. When we introduce an antibiotic into a bacterial population, within just a few generations, sometimes within hours, some bacteria will have acquired resistance genes, either through mutation or by receiving them from other bacteria that had previously encountered similar challenges. From our human perspective, this can seem alarming when it comes to medical treatment. But from nature's experimental perspective, it's a beautiful example of rapid, collaborative problem solving. Bacteria don't compete only as individuals, they also cooperate as communities, sharing solutions to survival challenges across the entire microbial ecosystem. But bacteria's experimental capabilities go far beyond just swapping genes. They've also mastered the art of community living in ways that are just beginning to be understood by human scientists. Bacterial communities can form complex, multicellular structures called biofilms Think of them as bacterial cities, with different neighborhoods specialized for different functions. In a biofilm, some bacteria might specialize in producing the sticky matrix that holds the community together. Others might focus on processing nutrients. Still, others might serve as scouts, detecting changes in the environment and signaling the rest of the community. Some bacteria even sacrifice themselves for the good of the community, bursting open to release nutrients or defensive chemicals when the community is under stress. These bacterial communities engage in sophisticated communication through chemical signals, coordinating their activities across thousands or millions of individual cells. They can make collective decisions about when to grow, when to form protective structures, when to disperse to new locations. They're conducting experiments in multicellular cooperation that rival anything found in more complex organisms. Now let me introduce you to perhaps nature's most controversial experimental subjects: viruses. Viruses occupy a strange position in the living world. They're not quite alive in the traditional sense, yet they're undeniably biological entities that evolve, adapt, and participate in the ecosystem in profound ways. Think of viruses as nature's experiment in minimalism. They've stripped away everything unnecessary for survival, keeping only the bare essentials, genetic material, and the tools needed to reproduce inside other organisms. In doing so, they've become incredibly efficient at what they do, and they've also become powerful drivers of evolution in other species. When a virus infects a cell, it doesn't just reproduce itself. Sometimes it accidentally picks up pieces of the host cell's genetic material and carries them to the next host it infects. This makes viruses inadvertent genetic engineers, shuffling genes between different organisms and creating new combinations that wouldn't arise through normal reproduction. Many of the genes in your own genome actually originated from ancient viral infections. Over millions of years, viral genetic material has become incorporated into the human genome, and some of these viral sequences now perform important functions in human development and physiology. In a very real sense, you are part virus, a walking testament to nature's experimental approach to mixing and matching genetic material from different sources. Viruses also serve as evolutionary pressure that drives innovation in their hosts. The ongoing arms race between viruses and immune systems has led to some of the most sophisticated biological machinery on Earth. Your immune system's ability to recognize and respond to new threats, to remember past infections, and to distinguish between self and non-self, all evolved in response to viral challenges. But perhaps the most beautiful microscopic experiments are the partnerships between different species. Relationships so intimate and mutually beneficial that it becomes difficult to say where one organism ends and another begins. Consider the mitochondria in your cells, the tiny structures that generate most of the energy your body uses. These mitochondria were once free-living bacteria that, sometime around 2 billion years ago, were engulfed by larger cells. Instead of being digested, these bacteria began living inside their hosts, providing energy in exchange for protection and nutrients. This ancient partnership was so successful that mitochondria are now found in virtually all complex cells. They've retained their own DNA, separate from that of their host cells, and they reproduce independently. In a very real sense, you are not just one organism, but a confederation of organisms, your human cells working in partnership with billions of bacterial descendants that keep you alive by processing oxygen and generating cellular energy. This pattern of intimate partnership, called endosymbiosis, appears throughout the microscopic world. The chloroplasts in plant cells that conduct photosynthesis were once free-living bacteria. Many other cellular structures may have originated from ancient partnerships between different types of microorganisms. These partnerships reveal something profound about nature's experimental approach. Sometimes the most successful experiments involve not competition, but cooperation so complete that the participating organisms essentially become a single entity. The boundaries between self and other, between individual and community, become beautifully blurred in the microscopic world. The microscopic experiments happening right now in your own body are staggering in their scope and complexity. Your gut contains trillions of bacterial cells representing hundreds of different species, collectively called your microbiome. These bacteria help digest your food, synthesize vitamins you need, train your immune system, and even influence your mood and behavior through chemical signals that affect your brain. Recent research suggests that the bacterial communities in your gut are in constant flux, changing in response to what you eat, how much you sleep, your stress levels, and countless other factors. These communities are conducting ongoing experiments in community composition and function, constantly adapting to changes in their environment, which is, of course, your body. In many ways, you're not just one organism, but an ecosystem, a walking, talking habitat for trillions of microscopic experimental subjects. The health and stability of this ecosystem affects every aspect of your well-being, from your physical health to your mental state. You are both the environment in which these experiments occur and a participant in the experiments yourself. And these microscopic experiments aren't limited to the inside of your body. Right now, in the soil beneath you, in the water around you, in the air you breathe, trillions upon trillions of microscopic organisms are conducting experiments in survival, adaptation, and community formation. In every teaspoon of soil, there are more bacteria than there are people on Earth. These soil bacteria are conducting experiments in decomposition, nutrient cycling, plant partnership, and chemical communication. They're breaking down dead organic matter and recycling it into forms that plants can use. They're forming partnerships with plant roots, trading minerals for sugars. They're producing antibiotics and other chemicals that shape the composition of their communities. In the ocean, microscopic plankton are conducting experiments in photosynthesis, in floating, in avoiding predators, in surviving in an environment where nutrients are scarce and dilute. These tiny organisms produce much of the oxygen you breathe and form the base of food webs that support all ocean life. Even in the most extreme environments on Earth, boiling hot springs, highly acidic pools, deeply buried rock formations, microscopic organisms are conducting experiments in survival under conditions that would instantly kill larger organisms. These extremophiles, as they're called, reveal the incredible creativity of life's experimental programs and hint at the possibility that similar experiments might be occurring on other planets with very different conditions from Earth. As you rest there, breathing gently, consider this wonderful truth. With every breath you take, you're inhaling thousands of microscopic experimental subjects. With every sip of water, every bite of food, every moment of contact with the world around you, you're interacting with communities of microscopic organisms that are conducting rapid-fire experiments in adaptation and survival. The microscopic world is where evolution happens at its fastest pace, where genetic innovations are tested and shared most rapidly, where the fundamental chemistry of life is constantly being refined and improved. It's the engine room of the biosphere, the place where the basic experiments that support all larger life forms are continuously running. And perhaps most remarkably, these microscopic experiments have been running continuously for nearly 4 billion years. The bacterial communities in today's oceans are the direct descendants of the first living things on Earth, carrying forward an unbroken chain of experimental activity that spans almost the entire history of our planet. Trillions of experiments happening in every drop of water, every grain of soil, every breath of air. The microscopic workshop of evolution, where nature's creativity operates at a pace and scale that dwarfs anything happening in the more visible world of larger organisms. This is where the real action is in nature's experimental program in the invisible realm of the very small, where life continuously reinvents itself at a speed that matches the rapid pace of change in our modern world. As you drift deeper into relaxation, carried by the gentle rhythm of your breathing, remember that each breath connects you to this vast, ancient, ongoing, experimental program. You are not separate from these microscopic communities, you are part of them, participant in them, dependent on them. In the beautiful, invisible workshop of the very small, the experiments that sustain all life continue their ancient work, as they have for billions of years, as they will for billions more. As you settle even deeper into your comfortable space, perhaps adjusting your blanket, or finding that perfect position that lets you truly relax, I want you to imagine something both beautiful and profound. Picture Earth's climate not as a fixed backdrop against which life plays out its dramas, but as something more dynamic, the constantly shifting experimental conditions in nature's vast laboratory. Just as a scientist might adjust the temperature, humidity, or chemical composition in a laboratory to test how organisms respond under different conditions, Earth's climate has been continuously changing throughout the history of life, creating an ever-evolving experimental environment that has driven some of evolution's most remarkable innovations. Right now, as you breathe in and out, you're experiencing just one moment in this climate laboratory's 5 billion year experimental run. The oxygen you're breathing, the temperature that feels comfortable to your skin, the atmospheric pressure that allows your lungs to work efficiently, all of these conditions are the current parameters in an experiment that has been running since life began, with the settings constantly being adjusted by the complex interactions between living organisms, geological processes, and astronomical cycles. Let me take you on a journey through some of nature's most significant climate experiments, beginning with perhaps the most dramatic parameter change in Earth's history, the Great Oxidation Event, around 2.4 billion years ago. Imagine Earth's atmosphere before this event thick with methane, carbon dioxide, and other gases, but almost completely lacking the oxygen that you depend on for every breath. For the first 2 billion years of life's existence, this was the experimental condition, an oxygen-free world where life had learned to extract energy from other chemical processes. Then, gradually, as photosynthetic bacteria began releasing oxygen as a waste product, the experimental parameters began to shift. From the perspective of most existing life forms, this was a catastrophic poisoning of their environment. Oxygen was toxic to them, disrupting their carefully evolved metabolic processes. It was as if someone had gradually been turning up the concentration of a poisonous gas in the laboratory, threatening to end the experiment entirely. But here's where the beauty of nature's experimental approach becomes clear. Instead of ending the experiment, the changing conditions opened up entirely new experimental possibilities. Some organisms evolved ways to not just tolerate oxygen, but to use it as a powerful fuel for more efficient energy production. This led to the evolution of more complex cells, then multicellular organisms, and eventually to creatures like you who can't survive without the very gas that was once a deadly poison. The Great Oxidation Event reveals something profound about how climate serves as experimental conditions. Even changes that seem catastrophic from one perspective can become opportunities for entirely new forms of life from another perspective. The organisms that went extinct during this event weren't failures. They were successful experiments adapted to one set of conditions that couldn't adapt quickly enough when those conditions changed. The organisms that survived and thrived represent successful experiments in adaptation to new conditions. This pattern has repeated throughout Earth's history, but perhaps nowhere more dramatically than in the Ice Age cycles that have dominated the last few million years. Imagine Earth as a laboratory where the experimenters periodically adjust the global thermostat, cooling the planet down for tens of thousands of years, then warming it back up, then cooling it again, in cycles that have repeated dozens of times. Each Ice Age cycle has been like running the same experiment over and over again, but with slightly different parameters each time. How do forests respond to gradual cooling? How do animal populations adapt to the advance and retreat of glaciers? What happens when sea levels drop and expose new land bridges between continents? What innovations emerge when familiar habitats disappear and new ones form? The Ice Ages have been nature's repeated stress tests, challenging life to adapt to dramatic changes in temperature, precipitation, and habitat distribution. And life has responded with remarkable creativity. During Ice Ages, many species developed migrations patterns that tracked the moving climate zones. Others evolved physiological adaptations for cold tolerance. Some learned to hibernate or enter other forms of reduced activity during harsh seasons. But perhaps even more importantly, the Ice Age cycles created a kind of evolutionary pump, repeatedly fragmenting and reconnecting populations, creating opportunities for isolated groups to evolve in different directions, then bringing them back into contact to share their innovations. The advance and retreat of glaciers created highways and barriers that shaped the movement of genes and species across the landscape. Humans evolved during this period of repeated climate experiments. Our species emerged during the Ice Ages, shaped by the challenges and opportunities of a world where the experimental conditions were constantly shifting. Our remarkable adaptability, our ability to use tools and clothing to extend our physiological limits, our capacity for complex social cooperation, all of these may have been forged in the crucible of Ice Age climate variability. And now, as you rest here in this moment, we find ourselves in the middle of the latest climate experiment. But this one is different from all the others. For the first time in Earth's history, one of the experimental subjects, our species, has become powerful enough to influence the experimental conditions themselves. The current changes in Earth's climate represent something unprecedented in the planet's history. Rapid experimental parameter changes driven not by geological or astronomical cycles, but by the activities of living organisms. We're conducting an inadvertent experiment in rapid climate change, testing how quickly ecosystems can adapt to changing conditions, and discovering both the resilience and the vulnerabilities of the systems we depend on. This ongoing climate experiment is revealing remarkable innovations as species respond to changing conditions. Trees are extending their ranges toward the poles as temperatures warm. Some animals are shifting their breeding seasons to match changing seasonal patterns. Marine organisms are exploring new habitat ranges as ocean temperatures change. Plants are experimenting with new flowering times and growth patterns. But the rapid pace of current climate change also reveals the limits of adaptation. While nature's experiments have always involved some extinctions alongside new innovations, the current rate of change is challenging many species' ability to adapt quickly enough. Some experiments that were successful for millions of years are failing under the new conditions, while others are discovering unexpected opportunities in the changing world. From the deep perspective of geological time, even these current changes represent just another experimental phase in Earth's long history. The planet has experienced dramatic climate shifts before, and will again. Life has survived ice ages, volcanic cataclysms, asteroid impacts, and other massive disruptions to the experimental conditions. But from the perspective of individual organisms alive today, including us, these changes represent profound challenges that are reshaping ecosystems in real time. We're witnessing evolution in action as species respond to new selective pressures created by changing climate conditions. There's something both challenging and oddly comforting about viewing climate change through the lens of nature's experimental approach. The changes we're experiencing are not separate from natural processes, they're part of them, even if they're occurring at an unprecedented pace and for unprecedented reasons. Life has always been an experiment in adaptation to changing conditions, and that experiment continues even now. The question becomes, what can we learn from nature's long history of successful adaptation to changing experimental conditions? How can we participate more consciously in the climate experiment, using our unique capabilities as tool-using, forward-thinking organisms to help guide the experiment toward outcomes that preserve the magnificent diversity and complexity that billions of years of previous experiments have produced? As you breathe slowly and feel yourself relaxing even further, consider that every breath you take connects you to this vast, ongoing climate experiment. The oxygen in your lungs was produced by photosynthetic organisms responding to current atmospheric conditions. The carbon dioxide you exhale will become part of the experimental parameters that influence plant growth and atmospheric composition. You are both subject and participant in this experiment, both affected by changing conditions and capable of influencing those conditions through your choices and actions. In this moment of rest and reflection, you're taking a brief pause in the middle of one of the most significant experimental phases in Earth's history, a phase where the experimental subjects have become conscious of the experiment itself and are grappling with their responsibility as both participants and co-creators of the experimental conditions. Change as both challenge and opportunity, as it has always been in nature's laboratory. The experimental conditions continue to shift, as they always have, and life continues to respond with creativity, resilience, and occasional magnificent innovation, as it always has. We are part of this ancient process, even as we face the unprecedented responsibility of consciously participating in shaping the conditions for future experiments. Now, as you continue to rest peacefully, your mind gently focused on these ideas while your body settles into deeper relaxation, I want to share with you perhaps the most extraordinary perspective of all: the possibility that we humans represent nature's latest and most ambitious experiment yet. What if I told you that right now, as you listen to these words, you are participating in something that has never happened before in the 4-5 billion year history of our planet? You are matter that has become conscious of itself. You are star stuff that has learned to contemplate stars. You are an arrangement of atoms that can wonder about atoms, a collection of molecules that can feel love, fear, curiosity, and joy. Think about this for a moment, as miraculous as it truly is. The carbon in your body was forged in the nuclear furnaces of ancient stars. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was created in stellar cores, or in the violent explosions of supernovas. And now, billions of years later, these recycled stellar materials have arranged themselves into a form so complex that they can contemplate their own cosmic origins. From nature's experimental perspective, consciousness represents an extraordinary innovation. For nearly 4 billion years, life experimented with increasingly sophisticated ways of processing information about the environment. Simple bacteria developed the ability to sense and respond to chemical gradients. More complex organisms evolved sensory systems that could detect light, sound, touch, and other environmental signals. Nervous systems emerged that could integrate this information and coordinate increasingly complex responses. But consciousness, the ability to not just process information but to be aware that you're processing information, represents a qualitative leap unlike anything that had emerged before. With consciousness, nature's experiments gained the ability to contemplate themselves. You possess something that no bacterium, no plant, no other animal appears to have in quite the same way. The ability to think about thinking, to be aware of your own awareness, to imagine possibilities that don't currently exist, and then work to make them real. This capacity for self-reflection and forward planning represents nature's experiment in creating matter that can consciously participate in its own evolution. But human consciousness isn't just an individual phenomenon, it's also a collective one. Through language, we can share the contents of our minds with each other in ways that no other species can match. When I describe a sunset to you, I'm transferring a pattern of neural activity from my brain to yours through the medium of words. When you read a book, you're receiving thoughts that were formed in someone else's mind, perhaps someone who lived centuries ago. This capacity for shared consciousness means that our species conducts collective experiments in ways that transcend individual lifespans. The knowledge and wisdom accumulated by previous generations doesn't die with them, it gets passed on, built upon, and expanded by subsequent generations. We are nature's experiment in cumulative learning, in collective memory that spans far longer than any individual life. Your technologies, from the simplest stone tools to the most sophisticated computers, can be understood as extensions of your biological capabilities. Just as a beaver's dam is an extension of its evolutionary adaptations for aquatic living, your tools are extensions of your evolutionary adaptations for problem-solving and environmental manipulation. But human technology has taken this concept of extended phenotype to extraordinary extremes. With clothing, you've extended your physiological tolerance to different temperatures and environments. With vehicles, you've extended your mobility beyond what your legs alone could achieve. With telecommunications, you've extended your ability to communicate across vast distances. With instruments like telescopes and microscopes, you've extended your sensory capabilities far beyond what your eyes alone could perceive. In a very real sense, the modern human is not just a biological organism, but a hybrid entity, part biology, part technology, seamlessly integrated in ways that make it difficult to say where the human ends and the tools begin. When you use a smartphone to access information, that phone temporarily becomes part of your cognitive system. When you drive a car, that car temporarily becomes part of your locomotive system. This integration of biology and technology represents nature's ongoing experiment in how far the boundaries of individual organisms can be extended. We may be witnessing the emergence of a new kind of evolutionary entity, one that evolves not just through genetic changes over generations, but through technological innovations that can be adopted within individual lifetimes. Your cities represent perhaps the most complex experiments in collective organization that nature has ever produced. A modern city is like a vast colonial organism where millions of individual humans coordinate their activities to create emergent properties that no individual human could achieve alone. Cities have metabolisms, they consume resources and produce waste. They have circulatory systems, networks of roads, pipelines, and electrical grids that transport materials and energy throughout the urban organism. They have nervous systems, communication networks that coordinate activities across the entire system. They even have something like immune systems, emergency services, and security systems that respond to threats and disruptions. And like all of nature's experimental systems, cities exhibit emergent properties that arise from the complex interactions of their components. Traffic patterns, economic systems, cultural trends, social movements all emerge from the countless individual decisions and interactions of urban residents, creating behaviors and capabilities that transcend what any individual human could plan or control. From this perspective, urbanization isn't separate from natural processes, it's the latest phase in nature's long experiment with collective organization. Just as the first multicellular organisms represented a breakthrough in cellular cooperation, and just as social insects developed sophisticated colony-level behaviors, human cities represent a new kind of superorganism emerging from the cooperation of intelligent individuals. But perhaps the most remarkable aspect of the human experiment is our growing awareness of our role as experimental subjects. Unlike other species, which participate in evolution unconsciously, we're beginning to understand our place in the vast experimental program that has been running for billions of years. This awareness brings with it both tremendous opportunity and tremendous responsibility. We can consciously choose to participate in evolution in ways that enhance the complexity, diversity, and beauty of life on Earth. We can use our technological capabilities to extend the reach of life into new environments, to preserve endangered species, to understand and protect the ecosystems we depend on. But our consciousness also makes us aware of our capacity to disrupt or damage the experimental systems that sustain us. We can see how our activities are affecting climate, ecosystems, and other species. We can recognize that our tremendous power comes with equally tremendous responsibility for the outcomes of our participation in nature's ongoing experiments. In many ways, we represent nature's experiment in creating ethical agents, organisms that can not only act, but can reflect on the consequences of their actions and choose to act in ways that consider the well-being of other organisms and future generations. This ethical dimension of human consciousness may be one of the most important aspects of our role in nature's experimental program. We may be the universe's way of developing a moral sense, a capacity for care and responsibility that extends beyond immediate self-interest to encompass the well-being of the entire planetary system. As you rest there, breathing gently, consider the extraordinary privilege and responsibility of being part of this consciousness experiment. Every thought you think, every choice you make, every moment of wonder or compassion you experience contributes to nature's ongoing exploration of what it means to be conscious, ethical, and creative beings. We might be nature's way of understanding itself, of reflecting on its own processes, of consciously choosing directions for future experiments. Through human consciousness, the universe has developed the capacity to study itself, to wonder at its own complexity and beauty, to care about its own future. This perspective offers both humility and empowerment. We are not separate from nature, we are nature becoming conscious of itself. We are not above the experimental process, we are the latest and most complex participants in it. And in this moment, as you listen to these words and contemplate these ideas, you are actively participating in the universe's ongoing experiment in self-awareness and self-reflection. There's something wonderfully recursive about this. Matter organized into human brains, contemplating how matter organized itself into human brains. The universe thinking about itself through the medium of human consciousness. Nature experimenting with creating experimental subjects that can consciously participate in designing future experiments. We might be nature's way of understanding itself, and in this quiet moment of reflection, you are part of that understanding unfolding. Rest in that knowledge, in the recognition that your consciousness is not an accident or an aberration, but perhaps the most beautiful and meaningful experiment that nature has conducted yet. As you settle even more deeply into this peaceful state, your breathing becoming slower and more rhythmic, I want to take you into perhaps the newest and most rapidly evolving laboratory in nature's experimental program. It's a laboratory that didn't exist just a few decades ago, yet it's already transforming life on Earth in ways both subtle and profound. We're entering the realm of digital evolution, where information itself has begun to behave like a living system, reproducing, mutating, competing for survival, and evolving at speeds that would make even the fastest adapting bacteria seem slow by comparison. Think about this for a moment. Right now, in the digital networks that span our planet, there are patterns of information that exhibit many of the characteristics we associate with life. They reproduce themselves, spreading from computer to computer, phone to phone, mind to mind. They undergo variations as they're copied and shared. Some versions survive and spread widely, while others fade into digital extinction. They compete for limited resources, our attention, our memory, our time. These patterns of information, ideas, images, videos, memes, cultural trends represent nature's latest experiment in evolution. The evolution of pure information, uncoupled from specific biological carriers, yet still following the fundamental principles of variation, selection, and inheritance that drive all evolutionary processes. Consider how a simple idea can spread through human networks. Someone has a thought, shares it through speech or writing or digital media, and that thought pattern gets copied into other minds. But it's not copied perfectly. Each person who receives the idea interprets it slightly differently, adds their own variations, combines it with their existing knowledge and experience. Some versions of the idea prove more compelling, more memorable, more shareable than others. These successful variants spread more widely, generating more copies of themselves. Less compelling versions fade away, forgotten and unreproduced. Over time, the idea evolves, shaped by the selective pressures of human psychology, cultural context, and technological affordances. This process mirrors biological evolution so closely that scientists have borrowed evolutionary terminology to describe it. We speak of viral content that spreads rapidly through networks. We talk about the survival of certain ideas and the extinction of others. We observe how information undergoes mutations as it's transmitted and transformed. But digital evolution operates at speeds that biological evolution cannot match. A biological generation might take years or decades, but an informational generation can occur in minutes or hours. A single tweet can spawn thousands of variations and responses within hours. A video can evolve through countless remixes and adaptations in a matter of days. This acceleration of evolutionary processes is creating entirely new forms of cultural and technological innovation. Software programs evolve through successive updates and modifications. Online communities develop their own languages, customs, and social structures. Digital art forms emerge, flourish, hybridize, and spawn new variants in continuous cycles of creative evolution. But perhaps the most profound aspect of digital evolution is how it's changing the nature of human intelligence itself. We're not just creating digital tools, we're integrating them into our cognitive processes in ways that extend and enhance our mental capabilities. When you use a search engine to find information, you're temporarily extending your memory system to include the vast databases of the internet. When you use GPS navigation, you're extending your spatial cognition to include satellite-based positioning systems. When you use translation software, you're extending your linguistic capabilities to include languages you've never learned. These digital extensions of human cognition are becoming so seamless and ubiquitous that they're changing what it means to be an intelligent agent in the modern world. The boundary between human intelligence and artificial assistance is blurring in ways that suggest we may be evolving into hybrid cognitive systems. Part biological brain, part digital network. This integration is happening not just at the individual level, but at the collective level as well. The internet has become something like a global nervous system, connecting human minds across the planet in ways that enable new forms of collective intelligence and collaborative problem solving. Consider how online communities can solve complex problems by combining the knowledge and skills of thousands of participants. How crowdsourcing platforms can accomplish tasks that would be impossible for any individual. How social networks can coordinate collective actions and social movements. How digital platforms can aggregate and process vast amounts of human input to generate insights that no single human could achieve. We may be witnessing the emergence of a new kind of evolutionary entity, a planetary-scale intelligence that emerges from the networked interactions of billions of human minds mediated by digital technologies. This collective intelligence exhibits properties that transcend what any individual human or computer system could achieve alone. But this digital evolution also raises profound questions about the nature of consciousness, identity, and what it means to be human. As our cognitive capabilities become increasingly distributed across biological and digital systems, as artificial intelligence systems become more sophisticated and autonomous, as the boundaries between human and machine intelligence continue to blur, we find ourselves grappling with fundamental questions about the future of consciousness on Earth. Are we creating artificial minds that might eventually surpass human intelligence? Are we evolving into a hybrid species that's part biological, part technological? Are we becoming nodes in a larger collective intelligence that transcends individual human consciousness? These questions don't have easy answers, but they point to the extraordinary nature of the evolutionary moment we're living through. For the first time in Earth's history, conscious beings are actively participating in the design of their own evolutionary successors. We're not just adapting to environmental pressures, we're creating new environments, new selection pressures, new forms of intelligence and consciousness. The pace of change in digital evolution is so rapid that it's difficult to predict where these processes might lead. Artificial intelligence systems are evolving capabilities that seemed impossible just a few years ago. Digital networks are becoming more complex and sophisticated at exponential rates. The integration of human and artificial intelligence is creating hybrid cognitive systems with unprecedented capabilities. Yet, from the deep time perspective of evolutionary history, even these rapid changes represent just the latest phase in nature's ancient experimental program. The same fundamental processes that have driven evolution for billions of years, variation, selection, and inheritance, continue to operate in digital realms, just at vastly accelerated speeds and with new types of substrate. As you breathe slowly and feel yourself sinking deeper into relaxation, consider this remarkable moment in evolutionary history. You are living at the inflection point where biological evolution is giving rise to digital evolution, where consciousness is beginning to create its own evolutionary successors, where the experimental subjects in nature's laboratory are becoming conscious co-designers of future experiments. This raises a final, contemplative question that you might carry with you as you drift towards sleep. Are we still nature, or are we becoming something new? The answer might be both. We remain part of the natural world, subject to the same fundamental laws and processes that govern all life. Yet we're also becoming something unprecedented: conscious agents of evolution, creators of new forms of intelligence and consciousness, participants in experimental programs that we're designing ourselves. In this digital age, we're not separate from nature's experimental process, we're the leading edge of it. Every time you interact with digital technologies, every time you share information online, every time you use artificial intelligence tools, you're participating in the newest phase of evolution on Earth. The experiments continue, faster and more complex than ever before, and you are both observer and participant, both experimental subject and co-experimenter, in this beautiful, mysterious, rapidly unfolding exploration of what consciousness and intelligence might become. As you rest there in the quiet of this moment, you're taking a brief pause in the middle of the most rapid evolutionary transformation in Earth's history. Tomorrow, the experiments will continue, the digital evolution will accelerate, and you'll have countless opportunities to consciously participate in shaping the future of intelligence and consciousness on our planet and perhaps beyond. Are we still nature, or something new? Perhaps we're nature's way of transcending its own previous limitations, of experimenting with new forms of existence that honor the past, while exploring previously unimaginable futures. In this space between what we were and what we're becoming, in this moment of rest and reflection, you are perfectly positioned to appreciate both the ancient continuity and the revolutionary novelty of this extraordinary evolutionary moment. As you settle into this final phase of our journey together, perhaps pulling that blanket a little closer or finding that perfect position where every muscle can truly relax, I want to share with you one of the most comforting and profound realizations about nature's experimental approach. It's something that might change how you see not just the natural world, but your own place within it, your own struggles and imperfections, your own beautiful, messy, wonderfully human existence. Here's the question that has puzzled human minds for centuries. If evolution is supposed to create better and better adaptations over time, if natural selection is always favoring the fittest, then why isn't everything in nature perfectly designed? Why do we have wisdom teeth that don't fit in our mouths? Why do giraffes have a nerve that runs all the way down their necks and back up again when a direct route would be so much shorter? Why are there so many seemingly inefficient, redundant, or downright peculiar features in the living world? The answer, I believe, reveals something beautiful about the nature of creativity itself, something that applies not just to biological evolution, but to all forms of innovation, growth, and discovery, including the ongoing experiment of your own life. Nature doesn't optimize for perfection. It optimizes for possibility. Let me paint you a picture that might help you understand what I mean. Imagine two different approaches to creating music. In the first approach, A composer sits down with a clear plan, writes out every note precisely, and performers play exactly what's written on the page. The result might be technically perfect, with every note in its optimal place, no wasted sounds, no unnecessary repetitions. In the second approach, jazz musicians gather together with just a basic chord structure and begin to improvise. They build on each other's contributions, they explore unexpected directions, they sometimes play notes that clash before resolving into harmony. There are false starts, happy accidents, moments of pure inspiration that emerge from apparent mistakes. The result is messy, redundant, unpredictable, and often transcendently beautiful. Nature, it turns out, is a jazz musician, not a classical composer. This jazz-like approach to evolution explains so much about the wonderful messiness of life. Why do we have multiple backup systems for essential functions? Because redundancy isn't waste, it's resilience. Why do seemingly unnecessary variations persist in populations? Because what's unnecessary today might be exactly what's needed when conditions change tomorrow. Consider the beautiful inefficiency of genetic diversity. In any population of organisms, there's tremendous variation in individuals with slightly different versions of genes, slightly different responses to environmental challenges, slightly different capabilities and limitations. From an engineering perspective, this seems wasteful. Why not just keep the single best version of each gene? But evolution has learned something that human engineers are just beginning to appreciate. Diversity itself is valuable. When environmental conditions change, when new challenges arise, when familiar solutions stop working, it's that wasteful genetic diversity that provides the raw material for adaptation. The variations that seemed unnecessary or even detrimental under old conditions might be exactly what's needed for survival under new conditions. Your own genome is a beautiful example of this evolutionary jazz improvisation. You carry genes from countless ancestors, including some that seem to serve no current function, others that are turned off but could potentially be reactivated, still others that exist in multiple backup copies. You are, in a very real sense, a living library of evolutionary experiments, carrying within your DNA the accumulated improvisations of billions of years of genetic jazz. But perhaps nowhere is nature's commitment to beautiful inefficiency more apparent than in the realm of sexual selection and aesthetic evolution. Why do peacocks have such elaborate, seemingly impractical tail feathers? Why do birds of paradise develop such complex mating dances? Why do flowers invest so much energy in producing colors, scents, and patterns that serve no direct survival function? The answer is that beauty itself is an experiment, and one of nature's most persistent and successful ones. The capacity to appreciate beauty, to be drawn to patterns, colors, sounds, and movements that serve no immediate survival purpose, appears throughout the living world. This suggests that aesthetic sense isn't a luxury add-on to more basic survival functions, it's a fundamental feature of how conscious beings interact with their world. Your own sense of beauty, your ability to be moved by a sunset or a piece of music, or the way light filters through leaves, connects you to this ancient experimental program. When you find something beautiful, you're participating in the same processes that drive the evolution of butterfly wing patterns and bird songs and flower petals. And here's what's particularly beautiful about aesthetic evolution. It creates positive feedback loops of increasing complexity and diversity. A bird that develops a slightly more elaborate song attracts more mates and has more offspring. Some of those offspring inherit the tendency toward elaborate songs and develop them even further. Over time, bird songs become more complex, more varied, more beautiful, not because complexity serves any direct survival function, but because the appreciation of beauty itself has become part of the environment that shapes evolution. This principle extends far beyond biological evolution. Human culture exhibits the same pattern of aesthetic elaboration, the same tendency toward beautiful inefficiency. Why do we create art that serves no direct practical purpose? Why do we develop complex languages with thousands of nuanced words when a few hundred might suffice for basic communication? Why do we build cathedrals and compose symphonies and write poetry? Because we are nature's aesthetic experimenters, carrying forward the ancient tradition of creating beauty for its own sake, of investing energy and resources in experiences and creations that feed the soul rather than just the body. This perspective offers a profoundly different way of understanding your own imperfections, your own seemingly inefficient qualities, your own beautiful messiness. Those aspects of yourself that don't seem optimally designed for success in conventional terms might actually be part of nature's ongoing aesthetic and creative experiments. Your tendency to daydream might be nature's experiment in imagination and possibility. Your sensitivity to others' emotions might be an experiment in empathy and social connection. Your curiosity about seemingly impractical questions might be an experiment in the kind of open-ended exploration that leads to unexpected discoveries. Even your struggles and challenges might be part of this experimental process. The obstacles you face, the ways you adapt and respond to difficulties, the unique solutions you develop to life's problems, all of this contributes to the vast database of information about how conscious beings can navigate complex, ever-changing environments. Nature's jazz improvisation includes discord as well as harmony, includes mistakes that sometimes resolve into innovations, includes dead ends that teach important lessons about what doesn't work. Your own life, with all its unexpected turns, its moments of struggle and breakthrough, its unique combination of strengths and vulnerabilities, is part of this ongoing improvisation. There's something deeply peaceful about accepting this perspective. It means you don't have to be perfectly optimized for anything. You don't have to eliminate all inefficiencies, resolve all contradictions, or fix all your quirks and variations. You are exactly what you need to be for nature's current experimental phase, a conscious, creative, beautifully imperfect participant in the ongoing improvisation of existence. Your redundancies are your resilience. Your variations are your contributions to the diversity that makes adaptation possible. Your aesthetic sense is your participation in one of evolution's most beautiful experiments. Your imperfections are not bugs in the system, they're features, part of the beautiful inefficiency that makes creativity and innovation possible. As you rest there, breathing slowly and naturally, consider the possibility that you are perfect precisely because you are imperfect, complete precisely because you are unfinished, successful precisely because you are still experimenting. You are nature's jazz musician, improvising your unique melody in the vast, ongoing composition of life. The discord you sometimes feel in your life isn't a sign that something's wrong, it's the tension that creates the possibility for new harmonies. The redundancies in your capabilities aren't waste, they're the backup systems that allow you to adapt when circumstances change. The aspects of yourself that seem inefficient or impractical aren't flaws, they're your contributions to the beautiful, messy, wonderfully diverse experimental program that has been running for billions of years and will continue long after we're gone. In nature's jazz club, there are no mistakes, only explorations. There are no perfect performances, only authentic expressions. There are no final compositions, only ongoing improvisations that build on what came before while reaching toward possibilities that have never been tried. You are both musician and music in this cosmic jazz session, both improviser and improvisation, both the experiment and the one conducting the experiment. And in this moment of quiet rest, you can simply appreciate the beautiful inefficiency of it all, the wonderful, wasteful, gloriously imperfect process of existence, exploring its own infinite possibilities through beings like you. Imperfection as the source of all creativity, inefficiency as the foundation of resilience, redundancy as the basis of innovation. This is nature's way, and it is also your way. And there is profound peace to be found in accepting and celebrating the beautiful messiness of both. Now, as you rest in this moment of deep tranquility, your breathing slow and even, your body completely relaxed, I want to take you on one final journey, perhaps the most profound and peaceful journey of all. We're going to explore the nature of time itself, and how understanding evolution's relationship with time can offer you a perspective that is both humbling and deeply comforting. Close your eyes if they aren't already closed, and imagine that you can somehow step outside of time, looking down at the flow of existence like watching a vast river from high above. What you would see is something extraordinary. 4 billion years of evolutionary experimentation flowing like an endless stream, with each moment, including this very moment as you listen to these words, being simultaneously part of an ancient continuum and completely unique, never to be repeated exactly again. This is one of the most beautiful paradoxes of existence. Evolution is simultaneously a process that unfolds over vast spans of time and a process that exists only in the eternal present. Every moment is both a continuation of everything that came before and a fresh experiment, a new possibility, a unique combination of circumstances that has never existed before and will never exist again. Right now, as you breathe in and out, your body is conducting millions of evolutionary experiments. Your immune system is encountering new challenges and developing new responses. Your brain is forming new neural connections, adapting to new information, conducting its own small-scale experiments in learning and memory. Your gut bacteria are evolving. Your cells are dividing and differentiating. Your entire body is participating in the ongoing process of life, experimenting with new possibilities. But these experiments aren't happening in some abstract future or distant past. They're happening now, in this moment, in the eternal present. That is the only place where evolution actually occurs. The 4 billion years of evolutionary history that led to this moment exist only in the traces they've left in your DNA, in the structure of your cells, in the ecosystems around you. The future possibilities that evolution is exploring exist only as potentials that may or may not be realized depending on what happens in present moments like this one. This perspective that evolution exists only in the present moment offers a profoundly different way of understanding your place in the vast flow of life. You are not just the product of billions of years of evolution. You are evolution itself, happening right now. You are not just connected to the stream of life. You are the stream of life in this particular place, at this particular moment. Let me offer you an analogy that might help you feel this truth in your bones. Imagine evolution as a vast river that has been flowing for billions of years. The water that flows past any given point in the river is never the same water twice each moment, brings new molecules, new currents, new patterns of flow. Yet the river itself has continuity, character, direction. You are like a unique eddy in this river, a particular pattern of flow that has never existed before and will never exist again. You are made of the same water as the river, subject to the same currents and forces, yet you have your own distinct character, your own temporary but real existence as a recognizable pattern in the flow. From this perspective, your individual life is both infinitesimally brief and cosmically significant. Brief, because it's just one moment in a flow that has been continuing for billions of years and will continue for billions more. Significant, because you are the particular way that the universe is experiencing itself in this place and time, the specific experiment that existence is conducting through your unique perspective and choices. This river analogy helps us understand something profound about the nature of identity and continuity. The you that existed yesterday is not exactly the same as the you that exists today. Your cells have been replaced. Your thoughts have changed. Your experiences have accumulated. Yet there's a continuity of pattern, a recognizable flow that we call your identity. Similarly, the life forms that exist today are not the same as those that existed millions of years ago, yet there's a continuity of pattern, a flow of genetic and structural information that connects all life across vast spans of time. You are both completely new, a never-before-seen experiment in consciousness and creativity, and completely ancient, carrying within yourself the accumulated wisdom of billions of years of evolutionary experimentation. But perhaps the most comforting aspect of this temporal perspective is how it reveals that you are exactly where and when you need to be. In a river, every drop of water is exactly where the currents and forces of the system have brought it. There's no sense in which it should be somewhere else, no judgment about whether it's in the right place or the wrong place. It's simply where the flow of the system has carried it. Similarly, you are exactly where the flow of evolution has brought you. Your particular combination of genes, experiences, capabilities, and circumstances represents the universe's current experiment in consciousness as it flows through this particular space and time. You are not behind where you should be or ahead of where you should be. You are exactly where the river of existence has carried you, and that is exactly where you need to be. This perspective offers profound relief from the anxiety and striving that can characterize human existence. You don't need to figure out your purpose in some grand, cosmic sense, because you are already fulfilling it simply by being who you are, by experiencing what you experience, by contributing your unique perspective to the universe's ongoing exploration of its own possibilities. Your struggles are not signs that you're off course. They're part of the turbulence that creates new patterns of flow in the river of existence. Your moments of joy and insight are not rewards for being good. They're the universe celebrating its own discoveries through your consciousness. Your periods of confusion and uncertainty are not evidence of failure. They're the creative tension that exists at the edge of new possibilities. From this eternal present perspective, every moment of your life has been a unique experiment that has never been tried before and will never be tried again. The particular combination of your genetics, your environment, your experiences, your choices, and your responses creates experimental conditions that are absolutely unique in the history of the universe. This means that your life, whatever its circumstances, whatever its challenges, whatever its apparent successes or failures, is providing irreplaceable data to the universe's ongoing research program. Every emotion you feel, every relationship you form, every problem you solve, every mistake you make, every insight you gain contributes information that no other being in the history of existence could contribute. You are both the scientist and the experiment, both the observer and the observed, both the question and the answer in the universe's exploration of its own nature. And this exploration is happening not in some distant future when you've figured everything out, but right now, in this moment, as you listen to these words and feel your body relaxing deeper into rest. There's something profoundly peaceful about recognizing that you don't need to achieve anything more than what you're already achieving, simply by being conscious and alive. You don't need to become someone different or better. You are already the perfect experimental subject for this moment in the universe's evolution. You don't need to understand your purpose. You are already fulfilling it by being exactly who you are. This is not a passive perspective that suggests you should stop growing or trying or caring. Rather, it's a foundation of acceptance that can free you to grow and try and care from a place of peace rather than anxiety, from love rather than fear, from curiosity rather than desperate striving. When you act from this place of deep acceptance of your role as the universe's current experiment in consciousness, your actions become more authentic, more creative, more truly responsive to what each moment requires. You become like water in the river, flowing naturally according to the contours of the landscape while maintaining your own unique character and direction. As you rest there in this moment, feeling your breath move in and out naturally and effortlessly, you are participating in the same rhythm that has sustained all life for billions of years. The oxygen you're breathing connects you to the first photosynthetic bacteria that began releasing this gas into Earth's atmosphere. The carbon in your body connects you to ancient forests, to marine organisms, to countless other life forms that have participated in the great recycling of matter that makes all existence possible. You are both observer and observed in the universe's ongoing self-study. Through your eyes, the universe sees itself. Through your thoughts, it contemplates its own nature. Through your feelings, it experiences the beauty and complexity and mystery of its own existence. Through your choices, it explores new possibilities for how conscious beings can relate to themselves, to each other, and to the world around them. In this eternal present moment, you are exactly what 4 billion years of evolution has been building toward, and you are exactly what is needed for the next moment of evolutionary exploration. You are both the culmination of an ancient process and the beginning of futures that cannot yet be imagined. We are both observer and observed, both the experimenters and the experiments, both the question that existence is asking and the answer that it is discovering through our lives. In this recognition lies a peace deeper than understanding, a belonging more fundamental than achievement, a purpose more profound than any goal we could set for ourselves. You are the universe's way of experiencing this moment, this place, this unique combination of circumstances and possibilities. You are evolution in action, creativity in motion, the eternal experiment of existence, exploring its own infinite potential through the beautiful, temporary, irreplaceable phenomenon of your conscious awareness. As you drift towards sleep or deeper rest, carry with you this comforting truth. You are exactly where you need to be, exactly when you need to be there, exactly who you need to be. You are the perfect participant in this moment's experiment, the ideal subject for existence's ongoing research into its own nature and possibilities. The river flows on, carrying you gently forward into whatever comes next, and you are both the water and the pattern, both the current and the shore, both the journey and the destination in the endless, beautiful, ever-changing flow of life experimenting with itself through beings like you. In this moment of perfect rest, you are perfectly yourself, perfectly placed, perfectly timed, a unique and irreplaceable note in the universe's ongoing song of discovery, exploration, and endless, beautiful becoming. As you settle into the deepest level of relaxation, your body completely at ease, your mind peaceful and open, I want to leave you with one final thought, a perspective that encompasses everything we've explored together and offers a way of seeing that can bring comfort and wonder to any moment of your life. Imagine, if you will, that you could zoom out from your individual existence, out from your community, your species, your planet, your solar system, your galaxy, until you could see the entire universe spread out before you like a vast, three-dimensional tapestry woven from light and matter and energy and time. What you would see is not a completed creation, not a finished product, but something far more beautiful and dynamic. An infinite laboratory where creativity itself is experimenting with every possible form and pattern and possibility, where existence is engaged in an eternal process of discovering what it can become. The galaxies spinning in their vast spirals, the stars being born and dying in endless cycles, the planets forming and evolving their own unique stories, all of it part of the same experimental process that brings flowers into bloom and teaches birds to sing and creates the capacity for consciousness to arise from arrangements of matter that can contemplate their own existence. From this cosmic perspective, Earth is one of countless experimental chambers in this infinite laboratory, and life on Earth is one of countless experiments in how matter and energy can organize themselves into increasingly complex and beautiful forms. And you, resting here in this moment, are part of the most advanced experiment currently running in this particular chamber. The experiment in self-aware existence, in matter that has learned to love and wonder and dream. But here's what makes this vision not overwhelming but profoundly comforting. This infinite laboratory has no deadlines, no funding constraints, no pressure to produce immediate results. It has been running experiments for billions of years and will continue for billions more. It can afford to be patient, to try countless variations, to explore every possibility with the kind of unhurried thoroughness that only eternity can provide. This means that your life, with all its apparent urgencies and anxieties, is actually taking place within a context of infinite patience and acceptance. The universe is not rushing you to figure everything out, to achieve some specific outcome, to prove your worth through accomplishments. You are already worthy simply by existing, already valuable simply by participating in the great experiment of consciousness. Every challenge you face is not a test you must pass, but an experimental condition that the universe is curious to see how you'll respond to. Every joy you experience is not a reward you've earned, but a discovery the universe is making about the capacity for happiness and beauty that can emerge from conscious existence. Every moment of confusion or uncertainty is not a sign of failure, but an exploration of the creative tension that exists at the edges of the known. This perspective transforms every aspect of your existence, from potential problems to solve into fascinating experiments to participate in. Your relationships become experiments in how conscious beings can connect and care for each other. Your work becomes an experiment in how intelligence and creativity can be applied to the challenges and opportunities of your time. Your growth and learning become experiments in how consciousness can expand and deepen its understanding of itself and its world. Even your struggles and limitations become part of the experimental design rather than obstacles to your success. The universe is not only interested in what you can achieve when everything goes perfectly, it's equally curious about how you adapt when things don't go as planned, how you find meaning in difficult circumstances, how you maintain hope and love and wonder even in the face of challenges and uncertainties. From this infinite laboratory perspective, there are no mistakes in your life, only experimental results. There are no failures, only data points that contribute to the universe's growing understanding of what it means to be a conscious, creative, caring being in a complex and sometimes challenging world. This doesn't mean that your choices don't matter or that you shouldn't care about outcomes. Rather, it means that your choices matter precisely because they're contributions to this vast experimental program, and you can make them from a place of curiosity and creativity rather than fear and desperation. You can approach each day as a scientist approaches a new experiment, with genuine interest in what will emerge, with openness to unexpected results, with the understanding that every outcome, whether it matches your expectations or surprises you, completely provides valuable information about the nature of existence and your place within it. This scientific approach to living doesn't require you to be detached or unemotional about your experiences. Scientists can be passionate about their research, deeply invested in their discoveries, moved to tears by the beauty of what they uncover, while still maintaining the fundamental curiosity and openness that makes genuine discovery possible. You can love your life experiments just as intensely as a scientist loves their research, caring deeply about the outcomes while remaining open to whatever those outcomes might reveal about the nature of reality and your own evolving understanding of how to participate consciously in the ongoing creative process of existence. As you rest here in this moment of perfect peace, you are taking a brief pause in your participation in the infinite laboratory. But even this rest is part of the experimental process, the universe learning about the value of stillness, reflection, integration, the importance of pausing to appreciate what has been discovered before moving on to explore new possibilities. Your peaceful breathing right now is the universe experimenting with calm. Your sense of contentment and acceptance is existence discovering the beauty of being satisfied with what is while remaining open to what might emerge. Your feeling of connection to something larger than yourself is consciousness recognizing its own fundamental nature as part of an infinite creative process. Tomorrow, when you return to the active experiments of daily life, you can carry with you this perspective of yourself as a conscious participant in the universe's ongoing research program. Every interaction becomes an experiment in relationship. Every challenge becomes an exploration of resilience and creativity. Every moment of beauty becomes a discovery of the aesthetic possibilities inherent in existence. You don't need to figure out the meaning of life because you are the meaning of life the way that existence has learned to wonder about its own meaning. You don't need to find your purpose because you are purpose itself, the universe's way of experiencing intention, direction, and conscious choice. In this infinite laboratory, every moment is both a culmination of everything that has come before and a fresh beginning, a new experiment, a unique opportunity for existence to discover something about itself that it has never known before. And you, in your beautiful uniqueness, in your irreplaceable perspective, in your conscious participation in the ongoing creative process of reality, are exactly the experimental subject that this moment requires. As you drift into sleep or deeper rest, know that you are held within this infinite laboratory of love and creativity, where every being is valued not for what it achieves, but for what it contributes simply by being itself, where every experience is treasured not for its outcome, but for its participation in the endless, beautiful experiment of existence, learning about its own infinite possibilities through conscious beings like you. The laboratory never sleeps, the experiments never end, the creativity never stops. And you, resting peacefully in this moment, are both the beloved subject of these eternal experiments and the consciousness through which existence comes to know and appreciate its own boundless capacity for beauty, growth, and endless, wonderful becoming. Sleep well, dear experimental subject. Tomorrow, new discoveries await. As you drift towards sleep, gently carried by your breath, let's return to where we began. Why does nature never stop experimenting? The answer is beautifully simple. To stop experimenting would be to stop being alive. Every heartbeat, every breath, every moment of consciousness is nature continuing its ancient research program through you. You are not separate from these experiments. You are evolution in action, creativity in motion, the universe's way of experiencing wonder. Your dreams tonight will be small experiments in imagination. Your rest will be nature's experiment in restoration and renewal. As you sleep, billions of other experiments continue around you. Bacteria evolving, flowers opening, stars being born in distant galaxies. The great laboratory of existence never pauses, never rests, never stops exploring new possibilities. Take comfort in knowing you're part of something vast and patient and endlessly creative. Your life is both infinitesimally brief and cosmically significant, a unique note in nature's eternal song of discovery. Sweet dreams from all of us in the laboratory of existence. Thank you for sharing where you're listening from, for liking and subscribing, for being part of this community of gentle science. In the quiet of your rest, the experiments continue, as they have for billions of... In the quiet of your rest, the experiments continue, as they have for billions of years, as they will for billions more. You are held safely within nature's infinite curiosity, her endless love of possibility, her beautiful commitment to trying everything that could ever be. Sleep well, dear experimental subject. Tomorrow brings new discoveries.